This is an exam question about the effect of different wavelengths of light on the rate of photosynthesis. Those rates are plotted on the graph. This is called an action spectrum and it's shown in figure 1.1. So we can see we've got the rate of photosynthesis on the left hand side and we've got the different wavelengths of light along the bottom, ranging from 400 nanometers to 700 nanometers. So the units are important. Right, so if we look at what's going on this graph, here on the spectrum we've got red light. This point on the spectrum we've got blue light, and in the middle we've got green light. Okay, so they're the different colours of light based on the wavelengths in this spectrum. So if we look at this, we can see that red light and blue light are both used in photosynthesis because there's a high rate of photosynthesis at both those points. The green light is not used. So we've got use of red light, we've got the use of blue light, and green light is not used in photosynthesis because there's a low rate of photosynthesis. And that's the reason leaves look green, because they will be reflecting the green light, whereas they're absorbing the red and the blue light. Because we're given wavelengths, we need to make sure we're relating that to wavelengths. So between this peak here is between 420 to 450 nanometers. So that's a high rate. And we've got a second high rate peak here that is between, it's increasing from 650 to just before 700, so 690. So 650 to 690 nanometers. Again, make sure you're using units. There's a high rate of photosynthesis. And between this point here, so between 500 and 600, 650. Right, so between 500 to 650 nanometers. There's less rate, it's less effective. Don't say that there's no rate, because rate has not dropped to zero. The rate of photosynthesis has not dropped to zero. And that's, again, as we said, because this green light is being reflected at that wavelength. And the final thing you notice about this graph is that there's a rapid drop after 690. So greater than 690 nanometers, there's a sharp fall. Okay, so that's the graph explained. The question then says, describe the effects, so effects, more than one effect, of different wavelengths on the rate of photosynthesis. So we've got to link it to the rate. We've got to link wavelength to rate. So we can say blue and red light is used in photosynthesis. That 420 to 450 nanometers gives a high rate. And so does 650 to 690. So 650 to 690 nanometers gives a high rate. That between 500 and 650 nanometers, again, make sure you're mentioning the units. Right, and that's the green light, remember. that's less effective. We can say that it's reflected, so the rate is lower. So lower rate. And then the final point is this drop here. So greater than 690 nanometers, there's a sharp fall in the rate. So there's 5 marking points. That's worth 3 marks.